All right, guys, so let's take a look at average atomic mass. So the worksheet says, it's kind of crooked. Okay, better. It says rubidium has two isotopes, rubidium 85 and rubidium 87. So those are the isotope types. I'm going to write those in this first column. So I'm going to write rubidium 85. That's hard to see. Better. And I'm going to write rubidium 87. It says if the abundance of rubidium 85 is 72.2% and the abundance of rubidium 87 is 27.8%. So my percent abundance for rubidium 85 is 72.2%. And for rubidium 87, it's 27.8%. It wants to know what the average atomic mass of rubidium is. So my first step is to convert the percentage to a decimal. So I'm going to move the decimal 2 to the left. So 1, 2, I get 0.722. 1, 2, I get 0.278. The mass of one rubidium 85 is 85 grams. And the mass of one rubidium 87 is 87 grams. And I'm going to multiply these two together to get the weighted average atomic mass. So it works kind of like your grades work at school. So at school in physical science, your quiz grades are worth 25% and your test grades are worth 40%. So your test grades count more. The same thing goes for rubidium. Rubidium 85 is worth 72% and rubidium 87 is worth 27%. So most of my sample is rubidium 85, so it counts more than this rubidium 87. So to figure that out, I'm going to multiply these two together. So I have 0.722 times 85, and I get 61.37. I have 0.278 times 87, and I get 24.186. I'm going to add these together. So my average atomic mass is 85.556. Yes, I know you can look at the periodic table and get it, but we need to know where that number comes from. And I know this one isn't exactly like the periodic table. That's because we're using whole numbers right here for the weights, and the weights aren't whole numbers. So let's try another one together. It says uranium has 3 common isotopes. If the abundance of uranium-234, so that's my first isotope, is 0.01%, so it's 0.01%. I'm going to move this decimal 2 to the left, 0.0001. The abundance of uranium-235 is 0.71, so I'm going to write uranium-235, and it's 0.71%. I'm going to move my decimal 2 to the left, so 0.0071. And the abundance of uranium-238 is 99.28%. What is the average atomic mass of uranium? So I'm going to move this 2 to the left, 0.9928. 234 weighs 234 grams. 235 weighs 235 grams. And 238 weighs 238 grams. So I'm going to multiply So 0.0001 times 234, I get 0.0234. 0.0071 times 235, 1.6685, 0.9928 times 238, I get 236.2864. I'm going to add all these together. And I'm going to get 237.9783 grams as my average atomic mass. So the next three on this sheet are all the same way. So let's take a look at one on the back. That's kind of confusing. I didn't give you the little chart, so you can set it up on your own, but let's work this together because this one gives us the exact mass here. It doesn't give us the mass as a whole number. So let's take a look at this. Natural occurring chlorine that's put in pools is 75.53% chlorine 35. So my first isotope is chlorine 35. It makes up 75.53, oh dear, 0.53%. We're going to convert that to a decimal, so 0.7553. And its mass is 34.969. And 24.47%, I'm going to go ahead and write that down, chlorine 37. So I'm going to write that over here. I'm going to convert this to a decimal, multiply. It says the mass here is 36.966. It wants to know the average atomic mass. So 0.7553 times 34.969 is 26.412. 0.2447 times 36.966 gives me 9.0456. I'm going to add those two together. So 26.412 plus 9.0456 gives me 35.458 atomic mass units, because they used atomic mass units here and not grams. So that means if I look at this, that tells me that most of the chlorine is closer to chlorine 35 than it is closer to chlorine 37, because this final number is closer to chlorine 35. That answers this next question. The bottom one on the sheet is just like this one. If you have any questions, feel free to email me.